morning. Go ahead and find a seat. Or if I could ask that question differently, I might put it this way. Is it possible that some of you have misidentified the properties of a conference presentation? So I'm assuming that if you were going to write software to go query YouTube and pull out all the conference presentations on there, you probably would have limited your results to things that had sound, things that had slides. Not all of you, but at least some of you would have. And I think I might have as well before this talk. However, the Biennial National Association of the Deaf Conference might not have spoken words in their presentations. And likewise, the annual convention for the National Federation of the Blind might not have slides because of their audience. So the properties of a conference presentation are you have a presenter, you have an audience in the context of the conference. Your ability to identify and pick properties is proportional to your ability, or related to your ability, to write good programming code and good tests. And this is true whether you're writing property-based tests or not. Property-based tests just happen to formalize something that many of us do implicitly. Now, if you're going to use a property-based test library, you've got a part to play. Generally, it goes like this. You choose a specific, or I should say, a generic, not specific, a generic input type, right? You could tell your library that your function receives integers or strings, maybe strings with alphanumeric characters, but not other special characters. And then you pick a property to test. For the testing library, it will take the generic data type that you specified, and it will generate random input data for you. And then it will run a test over and over and over again using different data each time. So this has a few advantages, right? This type of testing will bring some benefits to you. And number one is it will require you to be very rigorous in your thinking. So we all think, right? I mean, you have to think every day, even before you get out of bed. But many of us just don't do a great job at it. And there are cultural pressures at play, at work here, right? I just say overall, our culture just has an anti-intellectualism to it in some spheres. Facebook and Twitter don't really encourage critical, deep thinking, right? And many of us are on Facebook and Twitter and other social media sites during the day sometimes. But regardless of the causes, many of us could use some practice thinking more deeply and more critically and more rigorously. Well, property-based testing will help you do that with your code. It'll help you think rigorously about your problem domain. Help you think rigorously about the requirements for your software, either at the system level or the function level. It'll help you think about your program behaviors. So property-based testing helps you think. It also helps with documentation. Now, if you're writing good tests, good example-based tests, that'll do it too. But I think you'll find that the property-based tests that you write, the documentation value will be a little bit different than example-based testing. It'll help you find edge cases in your code. LevelDB is a key value store that Google created. It's a library for a key value store. And one day, somebody filed a GitHub issue reporting a bug that they had found with a property-based testing library. And this is the list of steps, and this is the minimal list of steps that would be followed to reproduce this bug. Open new database, put key 1, value 1, close database, open database, delete key 2, which doesn't exist yet, delete key 1, which does exist but doesn't exist anymore because you deleted it, close database, open database, delete key 2 again, close database, open database, put key 3 in val 1, close database, open database, seek first. So, after this list of 17 steps, you would expect to see key 3. You didn't see key 3. You saw key 1. Probably not something the unit testers were thinking of when they wrote their unit tests. But we found it, not we, he, found it in his property-based tests. And once you know that a bug exists, but it's kind of hard to track down, a property-based testing library can help flush those out. So that's a lot of benefits. Now you might be asking, well, with all those benefits, why isn't everybody doing it? Right? Well, the short answer is because property-based testing is hard, frankly. At least it is when you first start out. So example-based unit tests are very concrete, and it might look something like this. If you were unit testing Elixir's merge function with their map module, right? It merges two maps. So you've got two maps. One has a key of A and a value of 1. The other map has a key of B and a value of 2, and you would expect that if you pass these two things to the merge function, you would end up with one map that has A and B as the keys and 1 and 2 as the values, right? So for most of you, this is nothing new, nothing surprising. However, with a property-based test, you don't know that your two maps are A1 and B2. It might look something like this. Now, I'm using stream data here. And so we're saying on this check all part that map 1 is a map of term and term. So this is stream data's way of saying we have a map, the keys could be anything and the values could be anything. And we do the same for map 2. So we've got two generic maps. And then we create a new map by merging those two generic maps together. And here's where I think many of you would get stuck. Because you don't know what your inputs are. I mean, you know they're maps, but what are you going to say about your merged map if you don't know what you started with? So we're gonna get some help. And we're going to get some help from an ice cream sandwich. Now, have you ever been to a restaurant and ordered something but then been brought the wrong thing? Well, we're all about to have a very bad experience with that. So welcome to Michael's ice cream shop. And you come to my ice cream shop, and you look at the menu and you think, I'd like an ice cream sandwich. And so you say to me, I'd like to order an ice cream sandwich, right? And I nod and I take your money, which I'm glad to do. If you wanted to, after the talk, I could take your money, just come find me in the hall. But I bring you this. And your first thought is probably not, thank you so much for looking after my health. This is going to be so much better for me than the ice cream sandwich I was thinking of. Now, you would say to me, if I wanted something healthy, I would have ordered something healthy. Please give me my ice cream sandwich. So I'd take it back, and then I would bring you this. And you say, this is not an ice cream sandwich. This is an ice cream pie. So I go back, and after dropping the plate accidentally, I bring you a new one, and I give you this. This is, no, Michael. This is a sliver of an ice cream sandwich. This is not an ice cream sandwich. I'm so sorry. Oh, I forgot the sandwich. I'm sorry. Let me go back and try again. I feel bad, so I bring you two. And at this point, many of you are thinking, this is a good deal. I paid for one, I get two. But then your conscience starts to get the better of you, and you think, his manager probably doesn't really want him to just give ice cream sandwiches away willy-nilly. And so, you say, I'm going to be honest, I ordered one, I just expect one. And I take it back and I start grumbling about how ungrateful you are for all that I do for you. And you also hear me say on my way back to the back of the store about how I'm glad that this particular plate is microwave safe, which should cause you some concern. And rightly so, because when I come back, I bring you something that looks kind of like a fried egg, since I've microwaved it in the microwave for a while, but it has, perhaps it was an ice cream sandwich at one point, but has ceased to be so any longer. So you, understandably, send it back. I bring you this. Nope. We try again, and I bring you this. And you say, it's missing the cookie crust. And I say, no, it's not. It has two cookie crusts, and they're both on the bottom. I wanted to be artistic, right? So all the ingredients are here. We have two cookie crusts, one layer of ice cream, and but this is not an ice cream sandwich. It's not what you ordered. So implicitly, with each of these things, you knew that it's not what you ordered. But what I want to do is identify the properties. I want to put words to why these things were wrong. So first, why was this wrong? So we have a type problem here. And this is a fruit. An ice cream sandwich, at best, if you're made with real ice cream, it's a dairy product. At worst, who knows what's in there. But we have a type problem here. With this, we've got a shape problem. And we've got a symmetry problem. Now, it doesn't really matter whether your ice cream sandwich is a circle or a square or a rectangle, right? It's got to be symmetrical in some way, shape, or form. Okay, here we've got a size problem. Okay, now I don't know exactly what the ideal dimensions of an ice cream sandwich are, but I can tell you that this is not those dimensions. We've got an emptiness problem, or a presence problem, depending on how you want to look at it, right? You would expect that a property of an ice cream sandwich would be that it exists, and I brought you something, and where's my ice cream sandwich? I don't know, but it's not here, right? So we've got an empty plate. Here we have an enumeration problem, right? You would expect the count of ice cream sandwiches to be 1. That's what you ordered, but I brought you 2. With this, we have a range problem. You might not have said this is obviously a range problem, but it is a range. For an ice cream sandwich to be an ice cream sandwich, the temperature has to be in a certain range, right? If it's too cold, you've just got a block of ice, right, and you break your teeth. If it's too warm, you get whatever this is, with a kind of nasty, bubbly-looking things in it. So it's not the right range, not the right temperature range. Here our problem is one of the relationship between the parts, right? So for an ice cream sandwich, you would expect a layer of ice cream to be sandwiched between 2 cookie crusts, right? I mean, it's under a cookie crust, but I wouldn't say it's sandwiched, right? Like, you wouldn't expect them to be like this. You would expect them to be like this, right? So not this, but this, right? And these parts are not related to one another in the right way. And then finally, we have an order problem here. All the parts are there. They're just in the wrong order. So when we list out the categories of the properties for our ice cream sandwich, here they are. Type, shape, symmetry, size, presence and emptiness, enumeration, range, and relationship of parts, and finally order. There may be more categories you could think of, but this is a good place to start. Now, let's bring this back to programming. When you think of your functions, and you think of what your functions should return, you're going to see pretty much the same thing. I'd change the relationship of parts to relationship of values, because that's what we work with in programming. But the potential categories of properties that apply to your functions are pretty much the same. Now, not all of these are going to apply to all of your functions. So, for example, order doesn't apply if your function just returns an integer. Now, we'll take each of these in part. Type could be strings, maps, lists, tuples. Shape could be you've got a map, you've got a list, you've got a list of maps, you've got a list of maps whose values are tuples that happen to have strings as the second element, right? So we're talking about your data shape. When we think of symmetry, sometimes your functions are going to return something where you would expect the items in your collection, for example, to be symmetrical. So if you had a function that returned a row of Pascal's triangle, you notice that there's some symmetry here. The first and last elements are the same. The second element is the same as the second to last element. When we think about size, you might ask how many elements are in your list or tuple, how many keys are in your map, how large or how small is your integer, how many characters are in your string. Presence or emptiness could mean different things depending on exactly what kind of function you're writing. So something that could represent emptiness would be an empty list, or a nil value, or an empty string. For enumeration, this sounds like size at first. I'm differentiating them this way. So when I think of size, I'm thinking how long is your string, or how big is your list, how many keys does your map have? I'm thinking of the collection as a whole. Right? When I think of enumeration, what I'm really getting at here is something akin to frequency. How many times does a specific element appear in your list? How many times does a specific character appear in your string? Range could apply to characters in a string, elements in a list, or other collection. It could apply to HTTP status codes. So if you were doing some endpoint testing on your web API, for example, you might write a test that says all of your return status codes should be in the 200 range. Or if the input was malformed, the parameters were malformed, maybe you would accept some status codes in the 400 range, but you certainly don't want any 500s. Relationship of value. So this is the Fibonacci sequence. So if you were to write a Fibonacci sequence generator, each triplet of numbers is related. So in the Fibonacci sequence, once you get past the first few, every element is the sum of the two elements before it. Right? So the third element, 1, is the sum of 0 and 1. 21 is the sum of 8 and 13. 55 is the sum of 21 and 34. So there's a relationship between the values here. And then finally, order. So if you're working with any kind of sorting in your collections, this would apply. So years and years and years ago, Kent Beck brought you test-driven development. Dan North brought you behavior-driven development. So it's my privilege at ElixirConf 2018 to bring you ice cream-driven development. So if you're going to tweet something, this would be the tweetable moment right here. So let's apply this to programming, right? I mean, the theory's good, but they say in a conference presentation you shouldn't be abstract, right? So let's make it concrete. Let's say that you and your 5 best friends are playing a role-playing game one Friday night. And you suggest, well, how about some Dungeons & Dragons? And I'm like, no, we played that last week. And so somebody suggests programs and projects, which is like D&D, only it just takes the geekiness up a notch, right? And you are a level 3 programmer in a large yet soulless corporation. Your cubicle is an 8x8 room with one exit to the west. And a level 6 manager enters the room. The game master rolls a 20-sided die, and it's a 20. The manager is hostile. The manager looks around the room, makes eye contact, and begins to approach you with a sour look on her face. You can tell she's mad, and she attacks with an assignment to a project that is a dead-end project. using a 20-year-old technology that nobody else uses anymore. It's going to require 80 hours a week for the next 6 months of your life. And the worst part is, this particular project will bring absolutely zero business value to your company. So it's designed to suck the life out of you. And you try to parry, you try to defend, and say, well, I'm going to be on vacation for a lot of this time, but your defense doesn't work. So you try another one. Well, I don't know the technology, and the manager really just doesn't care. And just when you thought you were going to be enslaved to this project for the next few months of your life, a level 9 project manager intervenes. And she says, no, instead of being on this project, we're going to put you on another project where you're going to get to solve programming challenges for the next 2 weeks. All in the company time, all in the company dime. How great is that? So the first one is the 8 Queens puzzle. And the 8 Queens puzzle goes like this. So it's in the context of a chess set. And a chessboard is an 8x8 grid. And we're going to focus on 2 of the pieces, the queens. And the queen is a very powerful piece in chess because the queen can move any number of spaces in any one direction, up and down, left and right, across the diagonals. And in chess, we say that when one piece moves onto a space occupied by another piece, the attacker captures the defender. Here are the 2 rules for the 8 Queens problem. Number 1, there have to be 8 queens on the board. Easy enough, assuming that you have 8 queens. I know most chess sets come with 2, but let's say that you got a few extras, a few spares. And second, no queen may be in a position to attack any other queen. Now, being a good programmer, you know that the first thing you do when you get a programming problem of some sort is not to pull out your keyboard, it's to think. And so to help you think, you reach in your desk drawer and you pull out your chess set, which you just happen to have with you at work, because who doesn't have their chess set with them at work? And you start to move some pieces around the board, and you say, okay, I think I've got it. And your coworker looks over and she says, no, you don't. You've got 2 queens that can attack one another. They're on the same column. So you move some pieces around a little bit more. You move that top piece over, and you say, okay, I've got it. I've got a solution to the 8 queens problem. But your coworker says, no, you actually have 2 in the same row. So we've got queens that can attack one another. This means this is not a valid solution to the 8 queens problem. So you move that top right queen up 1, and you've got no queens in the same row. Check. Got no queens in the same column. Double check. However, you've got a queen on the same diagonal. So this isn't a valid solution. Now what you have to do is you have to write a function that returns a valid solution to the 8 queens problem. And because I like you, I'll get you started. Here you go. So don't say I never did anything for you. Now, if you were going to unit test this with your traditional example-based unit tests, your unit test might look something like this. Okay, it's going to assert that the result of your function matches a data structure that represents this. Okay, we have 8 queens on the board. No queen can attack another queen, right? Problem solved. Well, not quite. This is another valid solution to the 8 queens problem. And if you hard-coded the first thing, this second solution would satisfy the conditions of the problem, but it would cause your test to fail. So you might be tempted to hard-code both solutions in your unit test and match the result of your function against one of those 2 things. There are actually 92 solutions to the 8 queens problem. And if you hard-coded all 92 solutions, I'd hate to break it to you. A, that's a ton of work, but in this case, it's worth it, right? But I think your unit test would probably be fairly unmaintainable. But things get worse, because at this point, the game master rolls another 20-sided die, and it comes up as a 20 again. And a level 5 product owner walks into the room, and there is a change in requirements. Now, I realize that we're just playing a role-playing game together here, right? We're all friends here. We're just playing a game, and this would never happen in real life. right? This never happens in your companies. The market never changes, and the product specs always come in perfectly the first time. Nobody ever overlooks anything. But in this game, there's a change in requirements, and your 8-queen puzzle has just become an n-queens puzzle, where you no longer just have to solve for an 8x8 grid. You also have to solve for a 4x4 grid, or a 12x12 grid, or pretty much any size grid, except for 2x2 and 3x3. There are no valid solutions to the generalized problem for a 2x2 or 3x3 grid. So your function has just become this. It's not 8 queens anymore, it's n queens, and it takes an argument. And I've done the hard work for you by putting your code comment. I know you just would have been lost without me, without that help. Now, if you were still thinking that you were going to write some example-based unit tests for this and match the result of your function against some hard-coded set of values, realize that with a 27 by 27 grid, there are 234 quadrillion, 907 trillion, 967 billion, 154 million, 122,528 solutions. And I'm going to break it to you. In this scenario, not in every scenario, but in this scenario, example-based unit tests are the path to the dark side. Example-based unit testing in this case lead to anger. Anger leads to hate. Hate leads to suffering. And you will suffer if you try to start writing all those quadrillions of unit tests out. So let's step back and let's think of our problem again, right? We need a different angle of attack for this. So we could represent a solution like this, right? An 8x8 chessboard. And by the way, we're going to step back from the generalized problem, and we're going to make it concrete again. So let's just limit ourselves to an 8x8 board. Thinking back to our ice cream shop problem and some of the categories of properties that we had there, are there any that we could apply here? Well, there are. Otherwise, I wouldn't have used this as an example. What about type? Well, it's a list, right? What about data shape? Yeah, we can say something about the shape of the data as well, because it's a list of lists. Could we say anything about the size? We sure can. The outer list has 8 elements in it. And each of the inner lists also have 8 elements, or has 8 elements. Enumeration is at work here as well. How many queens are we supposed to have? 8. Okay, so we're counting specific values here. Now, if the overall grid is an 8x8, right, that means we have 64 spaces total, and 8 of those are queens, then we have 56 empty strings. So I'm representing emptiness here by an empty string. Now, you might be tempted to say that there's a property of a relationship between parts here, right? Because no queen may attack another queen. But that's going to be too general, because we've not thought rigorously yet about what it means for one queen to attack another one. So let's try to think of some more specific things we could say. So one, we could say that each row, or each of those lists, will have at most 1 queue. We could say, likewise, each column will have at most 1 queue. And each diagonal will have at most 1 queue. So there's a range here. It could have 0, it could have 1, at least for the diagonals. Now, the row and the columns actually must have exactly 1 queue, right? Because if one row or one column doesn't have a queue, that means that there's at least 2 somewhere else, which violates the constraints of the problem. So the properties of an 8x8 solution, we've got a list of lists, right? An outer list contains 8 lists. The inner lists have 8 elements each. We have 8 queues and 56 empty strings. Each row will have exactly 1 queue. Each column will have exactly 1 queue. And each diagonal will have at most 1 queue. Now, the properties of an n by n solution are very, very similar, except instead of saying 8, we just fill it in with n. We've got a variable now. Instead of saying 56 empty strings, we just take the size of the board, which is n by n, so n squared, and we subtract the number of queens out, which leaves us n squared minus n. And then properties 6, 7, and 8 are all the same. And our test might look something like this. So our width has to be a positive integer, and then we introduce a constraint here. So it either has to be 1 or it has to be greater than 3. We've got our solution, and we assert that, so this is just the first property. So is it a list, right? We write our assertion there. And we also iterate over each of the inner lists, and we just verify that they are indeed lists. So this is what a property test might look like for the first property. And if you were to write property tests for all 8 properties, you could be pretty confident that whatever solution your function, or every result your function had that satisfied those 8 properties would be a correct one. This is my son, Christopher. He's 9. We were doing some property-based testing together a few weeks ago. It was a chuckle. I realized some fathers may take their sons out camping or something like that. We were doing our bonding with with property-based testing, but he was able to track along with me. He was able to understand some of the things that I was saying, and he was actually able to contribute. I'd ask him leading questions, and he would say, well, so he'd be able to think through some of these things, right? And I had identified a few properties for this code kata that I was doing, and I had filled in the test bodies for most of them, except for the last one. Right? I had identified the property, I just hadn't written any of the code out yet. And he said, well, what are you going to do for this last one? And I said, well, I'm not sure yet. And completely innocently, right, didn't mean any kind of insult, he said, well, why don't you ask a real programmer? Well, son, actually, I am a real programmer. And again, innocently, he asked, well, why don't you ask a smarter one? Okay, thank you, son. So we've got type and shape, type and size, we've got size, type and enumeration, type, enumeration, and emptiness, enumeration, and range. How are we doing on time? 6, okay. So we'll do another one quickly. So second code challenge. Let's say you've got some rational numbers that you want to implement in Elixir. Right, rational numbers, if you think back to your middle school-ish days, it's like a fraction, right? You've got an integer on top and a non-zero integer on the bottom. You call the top the numerator and the bottom is the denominator. So a first pass implementation might look something like this. You've got some sort of constructor function. You're kind of making a new type here. And you're just going to use tuples to represent your rational numbers. The first element is your numerator. The second one is your denominator. And because you don't really want the rest of your system to know that you're dealing with tuples, you add some accessor functions. So the numerator function takes a rational number, as represented by your data structure, and it returns the numerator. And the denominator function does the same thing, but with a denominator, right? What you really want to test here is that your numerator function, given any rational number, or any rational number as represented by your data structure, is going to return your numerator. And your denominator is going to do the same with the denominator. So we're going to introduce a new category of property here, a new pattern. So we're going to set the type and enumeration and order, that kind of thing aside for now. So there's a pattern for property-based testing called round trip. And what it does is you do something, but then you negate it, or you perform the inverse of it. So, for instance, serializing and then deserializing. You would expect that when you deserialize the thing you serialized, you would end up with your original value, right? Or if you write to the database, when you read from the database, you would expect to get back the thing you wrote. Or when you encode, you would expect that when you decode, you get the original thing. So this is a variation of a round trip pattern. And you might write your property test kind of like this, where your number is your numerator is any integer, your denominator is a positive integer, and then your rational number is what you get with the result of your constructor function. And you would assert that when you give your numerator function a rational number, it's going to give you the numerator. Right? So it gives you one of the things you started with. And you don't have to know what the specific concrete values are. That's the beauty of this type of testing. If you had implemented your code in such a way that certain integers wouldn't work for some reason, this would catch them for you, given enough test runs. At least the probability of it catching, I'd say, would be high. And the nice thing is, if you wanted to change your implementation from using tuples to using structs, you could do that without having to change your tests. Or, if you wanted to be clever, you wouldn't even have to represent your rational numbers as data structures. You could represent them as functions. So now your constructor function returns a function. So this is a higher order function. And it closes over your arguments. And so when your numerator and your denominator functions get past your rational number, because remember, the rest of your system doesn't really need to know what the data type of your rational number is. It just needs to know that it's a rational number and that it can hand these things to your module, which will just do the right things with them, right? It calls a function and it's going to return the correct values. So this is somewhat courtesy of the Structure and Interpretation of Computer Programs book. They use Scheme, but we'll do it in Elixir since this is an Elixir conference. So, to recap, when you are starting off with your adventures in property-based testing, and you get to the point where that deer in the headlights look starts to appear on your face because you don't really know what to say about the result of your function because you don't know what the inputs are, not exactly, just remember our ice cream shop. Think of type, shape, symmetry, size, presence or emptiness, enumeration, range, relationship of values, and order. So even though it's hard, it's a skill just like any other skill. And once you get some more practice, you can be good at this. So now go write some tests.